All right, in this video, we're going to be going over the second half of section 2.7, so 2.7b. The first half of 2.7, 2.7a was about graphing absolute value functions, which we actually see a graph of here. But now what we're going to focus more on is how we moved from this parent function to a shifted function like you see here, and we're going to be doing it with general functions. So instead of having an absolute value function, we're going to be using f of x, the function notation, and then doing transformations onto that for any general function. So the idea behind the h and k as horizontal and vertical shifts and the a as a vertical stretch is going to be used now in this general function transformation form right here. So a is still going to be your vertical stretch. Okay, that's still a vertical stretch or a shrink if it's less than 1. And if it's negative, it's going to flip the graph. H is still going to be a horizontal shift, and K is still going to be a vertical shift. So if you read through these steps here, and we didn't really cover this in class because we got right to the examples because of time, and I think that might have been kind of detrimental to the lesson. So that's why I'm taking a look at this again here. The first step is you want to take care of the stretch or shrink. And we did write that in our notes. We did write something to the effect that you must you must stretch before you slide. And that's basically what this is saying here. Step 1 is to do the stretch or shrink. That'll also include flipping the graph as well. Step 2 is to reflect it. Okay, which we've basically combined those into one step. You can do those kind of at the same time. And then the third step is to translate it using the H and K. What we're going to do, though, is take a table of values, the original table of values of the function, and perform the operations on the x or y values, whatever is necessary. And the order of operations should take care of those steps in that order. But I still am going to write here that you must stretch before you slide. I think it's a good way to remember. You need to take care of A before you take care of H and K. And the stretching also includes reflecting, since that's also something that A affects. So for these examples, the examples are listed up here, A and B. We're actually going to do them down below. I put the graphs down below, so I try to color code with the green and blue here. Let's look at the original function, though. What I did was I took this original function. We don't have the actual function, just the points, but I took the original function and the points, and I put it onto each example down below. Not only A and B, but if you look down here, all of these are using that same graph. So I've put it on every single graph to start, and I've graphed it lightly because it's not really our answer. That's just kind of a way to show what it started as. So in A, they're asking us to find the graph of y equals 2 times f of x. That's an A value. A is a stretch or a shrink. In this case, it's going to be a vertical stretch. And since it's vertical, it's going to affect only the y value. So I want you to notice I've made a second table here. This red one, the blue one, is the original function. I've made a second table where I'm going to put my new values. Since A is a vertical stretch, my x values are going to stay exactly the same that they were originally. The y values, however, are going to be multiplied by 2, and that will stretch it vertically by 2. So I'm going to take these 3 y values and multiply them by 2. 0, 6, and 6. And now I'm going to plot those 3 points, 0, 0, 2, 6, and 5, 6. And you can see that this has vertically stretched the graph. The point 0, 0 remains where it is because it was on the x-axis. So when you stretch something vertically, since it wasn't shifted at all, anything that's on the x-axis will stay where it is. And you can see it visually looks like it was stretched by 2. In example B, we have an A value of -1, an H value of -2, remember H is the opposite, and a K value of 1. In fact, I'm going to write that right below here. A is -1, H is -2, and K is 1. So the -1 means that we're going to reflect, Negative 2 for an h value means that we're going to go left 2, and the k value of 1 means we're going to go up 1. So here's my new table ready here. Now, the only thing that affects the x value is that, the left 2. So the only thing that ever affects the x values is what's inside of that parentheses with x. So we're going to go left 2. So that means that we need to subtract 2 from all of our x values. So I'm going to take those x values 0, 2, 5 and subtract 2 from each of them. Negative 2, 0, 3. There, I've subtracted 2 for all my x values. That essentially shifts the graph left. Now I'm going to take my y values and I'm going to multiply them by negative 1 because of the a value, and I'm also going to add 1 because of the k value. So let's do that here, and I'm going to write it as well. Negative y plus 1. And because of your order of operations, you are going to be taking care of the reflection before you take care of the addition, or the sliding. So let's multiply these all by negative 1 and add 1. So 0 times negative 1 is 0, plus 1 is 1. And we'll have negative 3 plus 1 and negative 3 plus 1, so these are each going to be negative 2. So I have my new points, negative 2, 1, 0, negative 2, and 3, negative 2. So essentially, what we said in the beginning is this graph is going to be reflected over the x-axis, reflected vertically, and we're going to shift it left 2 and up 1. And if you look at the new red graph compared to the blue graph, and that's why I like having the blue graph on there, you can tell that's exactly what happened. Okay, let's take a look at our next 3 examples here, 5, 6, and 7. We're using the same original function. In 5 is much like the first example that we did. We are just going to multiply the y values by 1/2 because that's our a value. So I'm going to have x and 1/2 y. So 0, 2, 5, those don't change. 0, 1.5, and 1.5, taking half of those y values. And because f of x means y, I mean, that's literally what the function says, 1/2 times the y values. So we've got 0, 0, 2, 1.5, and 5, 1.5. And again, this is why we put that original graph on there lightly, because you can see that it actually looks like it was shrunk by 1/2, which it was supposed to be. Okay, this one's got a couple things going on here. A value of negative 1 again means that we reflect. And then we're going to go right 2 because h is negative 2. K is negative 5, which means we're going to go down 5. Okay, so you got to be careful here. Oh, and we're also going to have a reflection. I'm going to write that there so I don't forget. So I'm going to take care of my x values first. The x values, we're going to the right 2, so I need to add 2. So 0, 4, 7. With y values, we've got an a value of negative 1, and we're going to go down 5. So let's see, we're going to multiply these all by negative 1 and subtract 5. So we're going to have negative 5. 3 times negative 1 is negative 3, minus 5 is negative 8. And then we're going to get the same value here because those y values are the same. So we have 0, negative 5, 4, negative 8, and 7, negative 8. Oops. Oh, I see what I did wrong here. To not shift this over. That's supposed to be a 2. 0 plus 2 is 2. So we have 2, negative 5. There we go. And again, that's why I like putting that function on there, and then I look back up. It's okay to make a mistake, but that's why you check over your work. I looked back up here and said I'm supposed to be shifting over 2. That point didn't get shifted over 2, so I fixed it. And then I noticed where my mistake was, which I'm sure most of you did about 3 minutes ago. All right, last one here. We're going to multiply by 2, positive 2, so it's going to stretch it vertically by 2. So I'm going to have to multiply the y values by 2. I'm going to take care of that right away. The x values, we're going to go left 3. So I'm going to take x minus 3. I'll do that right away so I don't mess those up again. And then the negative 1 for k value means I'm going to go down 1. So I'm going to subtract 1 from my y values. So I'm going to double all my y values and then subtract 1. So we're going to have 0 because 0 minus 1 is negative 1. And then I'm going to double them and subtract 1 and get 5 in both cases. So we have negative 3, negative 1, negative 1, 5, and 2, 5. So we can see how these a, h, and k values affect any general function, just like they did our absolute value function.